So hello everyone, good morning. I'm really delighted to be able to join you virtually and sorry to not be there in person, but I do hope that we'll have a chance to catch up virtually after the event. My name is Professor Brent Mittelstadt. I am Professor of Data Ethics and Policy at the Oxford Internet Institute and also Principal Investigator at the Weizenbaum Institute in Berlin. And I'm very happy to be able to talk to you today about some of the work that I've done in this space of fairness and trustworthiness in the context of AI, and specifically, what exactly can we do, practically speaking, to make AI fairer? I'm a philosopher and ethicist by background, and so I always like to start with sort of first definitions or by taking a closer look at the sort of key concepts in any talk that I give and in any topic that I research. And today will be no different. I want to start out with sort of where this interest in fairness and trustworthiness in AI first came from before taking a closer look at fairness in particular to see exactly how we can translate it into practice and also what sort of pitfalls we have to avoid when we are doing so. So really where we started, or at least where we came to in the context of AI ethics, was a sort of initial interest in it as a research topic. Let's say in the 2010s is really when it started to take off, but really interest in this area can go back to 1980s or even before. But it really started to capture public attention and bring in many more people in a research sense when we started to suddenly see lots of frameworks of ethical principles being published by AI companies, by public-private partnerships. There were hundreds of these things that were published sort of in the late 2010s or so. And for the most part, they would turn on these concepts like fairness and trustworthiness, where the principle was that Google's AI program should always be accountable to people. Microsoft wanted to build AI systems that treat all people fairly. Benefit, empowerment, explainability. These were all these sort of concepts that were core to the initial push in AI ethics. There's been some really fantastic work over the years that was looking at, of these hundreds of frameworks that were published by governments, by companies, by all different sorts of organizations, whether there was any sort of common ground between them and where their principles were coming from and what sort of concepts they were actually interested in. So if you're interested more in sort of the content of these frameworks, I'd point you towards this project from the Berkman Klein Center in particular. But for our purposes, we can turn back to sort of a simplified view of this initial interest in AI ethics and how it turned into principles and vague concepts, with some work by the high-level expert group on AI that was set up by the European Commission, and also the AI for People project. So basically, that project took all that work that was put into by the different companies and public-private partnerships to publish those frameworks and boiled it back down to some of its key elements. And what they proposed is essentially that there are four core principles of AI ethics, one of which is fairness. Trustworthiness was not really sort of on the policy radar at this point, but you can imagine trustworthiness would be here if this was redone today. And so we are kind of back to this point where our interest in ethical AI or legally compliant AI is turning on these concepts that are very vague or at least open to interpretation. And so what we can call those concepts, or sort of the term for them, would be essentially contested concepts. So things like fairness are essentially concepts where you can have many different definitions or interpretations. Those different definitions can be very rationally held by different people based on their values, their political interests, and so forth. And when you implement those different definitions, those different meanings, they lead to very substantively different requirements in practice. And so really what these sort of concepts are doing, these concepts like fairness, is hiding fundamental normative and political disagreements. And so that has to be our starting point for understanding fairness and trustworthiness in AI, and really to understand the nature of the problem that we're dealing with here and the sort of work that we need to do to fix it or to answer these sorts of questions. So to take a very simple toy example, you can break down fairness into an approach that's based on individual merit or one that is based on group membership. So if we're making decisions like who should we hire for a job, maybe what we think is fair is that we go for the individual person that is highest performing or most meritorious, however we define that. And we think that is fair because we're basing it just on the individual. Whereas we might instead say, well, actually, we should take into account the membership of different candidates, the sort of demographics, the historical situation that different groups have found themselves in, and actually take those things into account, recognizing the fact that not everybody is starting on a level playing field. So you can rationally defend those two approaches to fairness, and that is exactly the sort of challenge that we are facing when we are trying to translate something like fairness or trustworthiness into requirements or design features or even just principles of how we design and use AI systems in a way that is clear and acceptable, sort of broadly speaking, to people affected by the system, but to regulators, to civil society, and so forth. So it's a very, very difficult task that we have here. And so the first area that I want to look at in sort of coming to terms with that task is, can the law, so in particular, can non-discrimination law or anti-discrimination law actually point us in a certain direction, where essentially the law can say, this is the way that you should interpret fairness, or at least this is a way to interpret fairness that would be consistent with sort of prior jurisprudence, prior interpretations of non-discrimination law. And so that's a question that I've been researching for a while with my group at the Oxford Internet Institute. In particular, we published 3 papers where we look at that different dimensions of that question in much greater detail. So essentially, what these papers are doing, and I point you towards them because I think they are very helpful for different aspects of sort of taking fairness and turning it into something that you can actually implement day to day with AI systems, is it's taking a critical look at the sorts of tools and definitions that the research community has come up with, looking at them through a legal lens and essentially saying, okay, how exactly does that work line up with legal precedent, with prior interpretation of relevant law? Where are the gaps between those two, and how can we close those gaps? And in some case, what are the reasons for those gaps? So in the first paper, Why Fairness Cannot Be Automated, what we did was look at essentially what is the method by which courts in Europe will interpret questions of equality. Do they have a set method that they follow for deciding when something is discriminatory or not discriminatory in questions of equality? Or is it much more sort of contextual or ad hoc? And unsurprisingly, what we found is that it is very, very contextual, very ad hoc. There's very little quantification that happens, but we did find this sort of gold standard that was put forth by the European Court of Justice as the best way to look as widely as possible when you are dealing with these questions of equality. And so in there, what we did is essentially interpret or translate that gold standard set forth by the European Court of Justice into a fairness metric that you can actually use and implement with AI. So I won't be talking more about that paper today, but I will be talking about the second one in a bit more detail, where we look at sort of the core aims of non-discrimination law, and again, how exactly technical work on these questions of fairness line up with it. And then I'll end by looking at the topic of the last paper, which is the phenomenon of leveling down, and essentially how quite often the way that we would achieve fairness in the context of AI or machine learning is by breaking models equally for everybody. It's not by making anybody better off, rather it's by making everybody equally worse off. So let me go back though to the bias preservation paper and just start with a very, very basic distinction that anybody with any sort of background in non-discrimination law will be very familiar with. But essentially what non-discrimination law is about, at least in the EU, is about fixing an unequal society. There's a very helpful sort of story that demonstrates the difference between 2 core concepts of non-discrimination law. So this is the case of the wise judge. You have a brother and a sister fighting over a cake. They can't decide how to cut the cake evenly, so they seek the advice of a judge to solve the problem. And the judge's solution is that the brother cuts the cake, but the sister gets to choose the piece. It's a very elegant solution to the problem of making sure that everyone gets an equal share of the cake. But what the solution does is ignore the context in which that choice is made, that choice about the size of the piece that you take or that you cut. The context may, in practice, very significantly impact our sense of what is actually fair in that situation. So imagine, for example, I tell you that the brother has just previously eaten a piece of cake a couple minutes ago, or if the sister has not had anything to eat in several days. That will probably change your sense of what would be fair in that case. So that translates very cleanly onto these concepts of formal equality and substantive equality that are very fundamental to non-discrimination law. Formal equality essentially means treating everyone the same. So we don't consider the differences between people. Everyone would get the same size piece of cake. It's essentially what would be called a fairness through unawareness approach, which is something that's been put forward in the context of fairness in AI or fairness in machine learning. Substantive equality, in contrast, tries to create a level playing field for people. So you take into account their differences both now and historically, and you can sort of try to re-weight things in different ways. So if you use equality of opportunity, for example, what you would do is look for different or additional criteria in whatever decision it is you're making. For example, hiring a person, deciding who gets an interview to get into university. You give different weights to the criteria, and what you're trying to do is essentially create equal opportunities rather than equal results or equal treatment for everybody that's involved. You're creating a level playing field defined by opportunities between people. So some people would get a bigger piece of the cake because they're more hungry. You can also have a sort of ratio approach, equality of results, where you'd say you have to hire, say, a certain number of people from this group and a certain number of people from this group. And there may be historical reasons why you would do that. It's also something that is commonly sought within an American non-discrimination context, at least where we're thinking about substantive equality in that context. So those are these two very basic concepts of non-discrimination law. And what we did in that piece of work was we mapped those concepts onto mathematical definitions of fairness that have been proposed by AI researchers and machine learning researchers. We reviewed the most popular sort of definitions of fairness, or what we'll call fairness metrics. And based on that review, we created this classification system that distinguishes between different fairness metrics, or these different mathematical definitions, based on how they deal with societal biases and therefore how they would align with the aims of non-discrimination law. So bias-preserving metrics would be ones that typically aim to match error rates between groups, so things like false positives, false negatives. What you're trying to do is preserve the error rates across time. So essentially, you're trying to not make things any worse than they currently are in society, or as they currently are sort of in the data set that you train your model with. So that would be an example of preserving the bias that you find in the data set and carrying it forward into the future. So there's a set of metrics where that is the aim, or that is essentially what they're doing in different ways. And the other set of metrics would be bias transforming ones. And these would essentially be other metrics, things that do things differently. They're trying to transform the bias that they find in that training data or test data. And for example, they would try to match decision rates between groups rather than error rates between groups. And so the basic sort of distinction between these two here is that what bias-preserving metrics try to do is preserve the status quo. So they're trying to preserve the error rate that they find in their training data. They're treating the status quo as a neutral starting point for deciding what is fair in the future. And by doing so, they're sort of taking for granted the justifiability of whatever bias that they encounter in their training data. Whereas bias transforming metrics do the opposite. They don't sort of set aside that question of whether pre-existing bias is justified or not. Rather, they sort of force the tester or the developer of the system to make a decision about whether the bias that they found is acceptable or not acceptable. So what we then did further is we mapped those categories back onto these core concepts of non-discrimination law. Unsurprisingly, bias-preserving metrics are much more about upholding formal equality, whereas bias-transforming metrics are much more about upholding substantive equality, although they can also, in some cases, be used to uphold formal equality. And so the problem that you have, going back to EU non-discrimination law, is that if the aim of EU non-discrimination law is to create a substantively equal society, which prior scholarship has essentially argued that that is the point of non-discrimination law, then if you use bias-preserving metrics in your AI systems, you're essentially pursuing fairness through means which do not hold up to legal scrutiny, or at the very least, which put you on very shaky ground in terms of living up to the obligations of non-discrimination law. And so that's a real problem. And what we wanted to highlight through this work is that there is this basic distinction between fairness metrics, and I should say fairness metrics are sort of the most popular or the most common output of research in this area of fair AI. And so if you're interested in creating fair AI systems within Europe, really what you want to go for is bias transforming metrics. We looked at the 20 most popular fairness metrics. We classified them as to whether they are bias preserving or not bias preserving. So problematically, we found that 13 out of 20 of the most commonly used ones are bias preserving, which would mean they would run into trouble in the context of non-discrimination law in Europe. But it's also a bit unsurprising that that's what we found, because so much of the work in this field has come out of North America, where they have a very different sense of anti-discrimination law. To make this even easier to sort of implement on a day-to-day basis, we also created this checklist for anybody that's considering using different sorts of fairness metrics. It basically just walks you through the different potential uses of fairness metrics and how to make decisions for these questions. I should say bias-preserving metrics are not without merit. They are very useful for things like diagnostic purposes, testing, research purposes. They're very useful for if you want to discover bias within AI systems. So it's not to say that they're problematic fundamentally. It's more that if you are looking at actually enforcing fairness on an AI system, so if you are looking to change how an AI system makes decisions or turns inputs into outputs in the real world, that's when using bias-preserving metrics on your model becomes very, very problematic. So the second piece of work that I want to talk about is about how we can avoid harm through this pursuit of fair AI. The problem that we have is that for whatever reason, this very sort of multifaceted, difficult concept of fairness has been very, very simplified, oversimplified, I would say, into something that is computable or quantifiable. After all, we're working with AI here. We're essentially working with numbers and computing. It's unsurprising to see that push towards quantification and computability. But at the same time, you're taking a qualitative concept and turning it into something purely quantitative. That's going to introduce problems. So we have these very simplistic mathematical definitions of fairness. In this case, I'm going to focus on the most common group of them, which would be group fairness. Where essentially what they're trying to do is make performance or outcomes equal between different demographic groups. So if you have a bunch of users that are divided into different demographic groups, your fairness metrics are trying to sort of equal out performance or outcomes between them. And the way that they tend to achieve that in practice is through something called leveling down. This is where I was talking about earlier. It's essentially arbitrarily making your system perform worse for groups where it currently performs better in order to make things equal across groups. So leveling down just refers to you're essentially leveling everybody down to the worst off group, worst performing group, the group that receives the most negative decisions, whatever it is you're thinking of. That's what we refer to with leveling down. And so that's a really problematic way to achieve fairness, because more often than not, there are other options available. It's not as if this is the only thing that you can do to make your system fair. Rather, it is the easiest thing to do. It is the lowest cost solution. It is the thing that doesn't require collecting any more data or sort of committing more resources to whatever the thing is that you're predicting or distributing or classifying. Rather, it's just, we'll make it equally bad for everybody, and it's fair according to one definition. So the way that leveling down would actually work in practice in the context of AI or machine learning is, first, you would try to improve performance of your model for the worst performing group as far as you possibly can. But then the second part is you would degrade performance for whichever groups are receiving better performance. So let's take the example of an AI system that is used for skin cancer screening. The system, and this is something that is sort of problematic with actual real world AI systems that do this sort of thing, is that they tend to have lower recall or just worse performance for darker skinned patients, which means that it ends up missing more cases of future cancer when you compare to the performance for lighter skinned patients. There's many reasons for why that is the case, but it is a widespread problem for these sorts of systems. And so the way that leveling down would work in the context of this hypothetical system that we would have is the system is going to classify our patients as either high risk or low risk of developing cancer in the future. And then it's going to give us a confidence score, essentially just a measure of how confident it is in that prediction. Now, the first part that I mentioned is that it's going to take some of the patients for which it is least confident in the worst performing group, and it's going to flip their prediction from low risk to high risk. And the basic idea here, or the motivation here as it relates to fairness, is that you'd err on the side of caution, and you would rather incorrectly predict that somebody will develop cancer in the future than miss a case of cancer that does develop in the future. Because by having this false positive, what you're doing is you're maybe subjecting the person to additional screening in the future, but it means that you're committing more resources to their health, and you're making it more likely that you will catch a case of cancer that ultimately develops in the future, that if you left the system alone or you left the predictions alone, that you would ultimately have missed. And the reason that we do this to the ones that are the lowest confidence is those are the ones where it's sort of lowest cost in terms of accuracy or performance loss for the system. We're taking the ones it's least sure about and flipping those to err on the side of caution. But where this turns into leveling down is with the other side of it, where you take the better performing group, in this case the lighter skinned patients, and again for the lowest confidence ones, you flip some of the patients from high risk to low risk. And this is obviously a very different sort of harm that you're creating. In the first instance, you're creating the harm of additional, potentially unnecessary screening that the patient has to go through. Whereas in this case, you're essentially putting the person at greater risk of having early treatment for their case of cancer in the future. So you're creating a very significant harm to the person's health, potentially, by flipping them from high risk to low risk. And the whole reason that we do this is not because it's necessary mathematically in order to do the initial flipping from low risk to high risk for the worst performing group. Rather, the reason we're doing this is because we have very simplistic definitions of what fairness is that say that the model is fair if you have equal recall or equal performance between these groups. And the fact that the one group still has higher performance than the other, even after the flipping occurs, mathematically looks wrong or looks bad. So you would do it literally just for mathematical convenience. So that's the phenomenon of leveling down. In this piece of research, we looked at sort of how common of a solution that actually is. So how frequently is this being used as a way to make systems fair? And what we found is that in some of the most commonly used fairness toolkits, so things like FairLearn and IBM Fairness 360, when you use group fairness methods and when you actually enforce them on your model, that they will ultimately achieve fairness by leveling down. We have lots of results in the paper to sort of back up that claim. But I want to turn more to this question of why exactly leveling down is harmful. So we already talked a bit about the inherent value of the thing that you're predicting or distributing. So something like accuracy of a system can be very sort of inherently valuable to people. But it's also about the sort of social and relational harms you can create by leveling down. So you can end up creating stigmatization between groups of people. You can erode sort of social solidarity, again, between groups of people. And by leveling down, you can essentially express unequal concern for one group over another. People tend to bring cases under equality law because they feel that they have been denied some sort of valuable good. And so what they are seeking is a betterment of their position or a betterment of the position of people like them. And by leveling down, you're essentially not giving them that. You're saying, okay, we're going to take that valuable thing away from the people who already have it. And in that sense, you're expressing unequal concern for the group that never had it in the first place or the person that never had it in the first place. So you have these sorts of harms, but the interesting thing is that leveling down has still very frequently been upheld as a legally acceptable solution to inequality in society. There's a number of cases, a lot of them coming from the US. This is one example where essentially a student that was denied entrance to the National Honor Society on the basis of pregnancy, marriage status, and living situation successfully sued her school district, claiming discrimination. So she won her case, but in response, what the school district did was just end their participation in the National Honor Society program rather than admitting her to it. So in this case, the student didn't gain access to the benefit they were seeking. Rather, the program was just ended for all students. We've had similar cases in terms of racial integration in the US, swimming pools. There's been cases of when integration orders were given, or desegregation orders were given, rather than cities actually admitting other people to the swimming pools. So they would have been whites only before. Rather than opening up the pools to everybody, what they did was just close down public pools for the entire city. And outside of the US, there have been cases as well within the EU, within the UK, where leveling down was essentially held up as an acceptable solution to these questions of equality. And that's the thing that ties all these cases together, is that despite these harms, leveling down is still quite often defended as a completely acceptable solution or answer to these questions of equality. There are cases in which leveling down is legally justifiable. So when you're trying to remove an unjustified historical advantage, for example, if you're removing the requirement to have a degree from a male-only university or male-only school from university admissions, quite often leveling down in that case would only be the only pathway available in order to achieve equality. You can also level down for purposes of civil action. We have a number of interesting cases in the paper, which I'll skip past now. You can also level down because you want to draw attention to a biased system before it can be deployed. So by achieving fairness or by enforcing fairness through leveling down, say on a facial recognition system that performs significantly worse for people with darker skin, you can essentially make the system untenable to actually deploy commercially. So there can be a sort of, I guess it's a form of civil action, but also a form of disruption by leveling down to make sure that people know that the systems are as biased as they are. But the question is, can you use any of those sorts of justifications in the context of fair AI? The answer is probably not, or at least not without a significant amount of additional work based on how AI development and research currently occurs. The first problem is that there is a very significant lack of engagement in work on fair AI and in development of fair AI systems with the case-specific context that would be required to justify leveling down in practice. The couple of examples I just gave you that require some knowledge of the context in which the system would be used in order to justify fairness through leveling down. Another is that there's a tendency to oversimplify and homogenize the value of the harms and the outcomes across these different use cases. So this would be, for example, if you assume that accuracy or cancer prediction is equally valuable for all people, there is a tendency to basically assign a single value to the good that is being distributed and assume it will benefit all people equally. Let's go back to the cake example of the value of a single piece of cake is not the same across all people. And the third is that the range of corrective actions that researchers and developers have available to them is quite often extremely limited. Quite often the answer to this will be, we need to develop a different sort of system. We need to do more testing. We need to collect additional data. We need to commit additional resources to the area in which the AI system is being used. Imagine, for example, AI used in a public healthcare system. But quite often the developers are required to make the system as fair as possible with the data available to them, with the resources available to them currently, and they don't have the power or the ability to basically demand more to actually fix the underlying cause of the discrimination or of the inequality that they've encountered in building the system. So our proposal is to not achieve fairness through leveling down, but rather to look at the underlying causes of bias and inequality in order to really achieve equality in practice. And specifically, one thing that we say that we can do, aside from sort of looking at these underlying causes, is to abandon this idea that we can get fairness by making two performance numbers equal to each other For example, by making our model equally accurate or have equal recall between different groups, and rather looking at setting what we call minimum performance thresholds across groups or minimum rate constraints across groups. Basic idea here would be is that you would avoid that second part of leveling down. You would say, okay, this is the performance threshold that we need to get the model to for all groups of people. As long as we get it to that threshold, then we will consider the model fair, and we're not going to arbitrarily make it perform worse for other groups just to try to satisfy some very simplistic definition, mathematical definition of fairness. So much more on the implementation and testing of this idea in the paper, but I realize I've already run over time, and I don't want to push the schedule back any worse than I have, especially with not being there. So I will just end here, say thank you so much for your attention. Again, sorry to not be there with you in person. I hope that you enjoyed the talk, and I'm always available via email if you have any further questions or further discussion. Thank you, and enjoy the rest of your day.